In 1935, a fighter pilot strapped himself to a rocket-powered sled and discovered something that would change spaceflight forever, but nobody understood it yet. That pilot's name was Wiley Post. He wasn't trying to study weightlessness. He was testing a pressurized cabin, a suit that would let him breathe at altitudes where the air runs out. What he found instead was a problem that would haunt every rocket engineer for the next 2 decades. How do you keep a human being alive when gravity stops working? See, spaceflight wasn't really a problem for engineers. Rockets existed. Trajectories could be calculated. The existential question was different. Would the human body simply break? Not from acceleration. Pilots had survived that for years, but from the absence of it, from floating. By the late 1940s, the U.S. military had a problem. They were sending test pilots higher and faster than ever before. Chuck Yeager broke the sound barrier in 1947, but the higher you go, the closer you get to space. And space, they realized, was an environment they couldn't test on the ground. Enter aviation medicine, a small, overlooked field of military doctors who studied what happens to pilots under extreme stress. They weren't rocket scientists. They were something more useful. They were willing to experiment on themselves. In 1951, a man named John Paul Stapp volunteered for what might be the most brutal medical experiment in American history. They strapped him to a rocket sled and accelerated him to 632 miles per hour. Then they stopped it in 4 seconds. The deceleration force, 46 times normal gravity. Stapp lived, his eyes bled, his ribs cracked, his vision went black, but he lived. And more importantly, he proved that the human body could survive forces that should have killed it. The data he collected became the foundation for understanding how astronauts could survive launch. But acceleration was only half the problem. What happened once you reached orbit? What happened when gravity went to zero? The answer came from an unexpected place: the parabolic flight. A pilot would fly a steep arc up, then down, creating brief windows of weightlessness. In 1951, the Air Force began using a modified C-131 transport plane to study it. Pilots volunteered to float for 20-30 seconds at a time. Those 20 seconds changed everything. Aviation medicine doctors discovered that weightlessness didn't kill you. It disoriented you. It made your inner ear scream. Your body would swell. Your sinuses would fill. But you could adapt. You could train for it. This was the breakthrough that nobody talks about. Not rockets. Not computers, not trajectory math. It was aviation medicine doctors figuring out that humans could survive the space environment if we understood how to prepare them. By 1958, when NASA was founded, the agency didn't have to solve zero-G. The Air Force had already done it. NASA just had to listen. And they did. The first astronauts weren't scientists, they were test pilots, Chuck Yeager's peers, people trained in the parabolic flights. Alan Shepard's suborbital flight in 1961 wasn't a leap into the unknown. It was the culmination of a decade of controlled experimentation. Aviation medicine had mapped the territory. They'd measured the heartbeat. They'd documented the adaptation. They'd proved the human body could do this. What's striking is how invisible this became. History remembers the rockets, it remembers the capsules, it remembers the astronauts' names, but the aviation medicine doctors, Stapp, von Beck, the engineers of the parabolic flights, their footnotes. Yet every astronaut who floated in microgravity, from Shepard to Gagarin to the crews on the International Space Station today, benefited from knowledge forged in those rocket sleds and parabolic arcs. The path to space wasn't built by dreaming. It was built by measuring, testing, and refusing to assume. This is why aviation medicine matters. It's the discipline that turned the impossible into the inevitable, not through theory, through evidence, through volunteers who strapped themselves to machines and said, "We need to know." So when you watch footage of astronauts moving weightlessly through a spacecraft, remember, that wasn't magic. That was medicine. It was decades of careful, methodical study by people who understood that before you could reach the stars, you had to understand the human body itself. The genesis of zero-G wasn't a moment. It was a discipline. It was aviation medicine saying, "We don't know if this is possible, but we're going to find out one test, one volunteer, one parabolic arc at a time." Subscribe to uncover the hidden stories behind spaceflight, the ones history glosses over but science never forgets.